In example 5, we're going to try and develop a formula to find the nth derivative for the function given by y equals sine x. I'm going to start with the first derivative, and I'm going to write that as dy by dx. The derivative we know of sine x is cos x. If I look for the second derivative, it's going to be the second derivative of the function y in the variable x. So now I'm looking for the derivative of cos x, and we know as well that that is minus sine x. Continuing like this, I'm going to find the third and the fourth derivatives. So the third derivative is going to be minus the derivative of sine x, so it's going to be minus cos x. And the fourth derivative, which is the derivative of the third derivative, is going to be minus sine x, so that's going to give me sine x. Have you noticed that we've got back to our original function of sine x? So we clearly are going to work in a loop, and our loop is going to work in 4 parts. If I make a table on the right-hand side, and I have my first derivative here, and then my second derivative, my third, and my fourth derivative, it stands to reason that the fifth derivative is going to be cos x, the sixth minus sine x, the seventh derivative minus cos x, and the eighth derivative is once again sine x. Continuing in this way, I'm going to try and create a pattern so that I can work out which terms are going to give me the first, the second, the third, or the fourth option. So I've got 9, 10, 11, 12, 13, 14, 15, 16. I'm going to stop at the 16th derivative, and I'm going to now start to develop a pattern. I'm going to develop a pattern for each row. Now, can you see that I have the number 1, 5, 9, and 13? Number 1 is the first number in my pattern, and so I'm going to call that number A. If I take a look at the consecutive numbers, there's a common difference. Every time when I take the number on the right and I minus the number on the left, I'm going to have a difference of 4. If I now substitute the A and the common difference into the formula of A plus the term number minus 1 times by the common difference, I'm going to get the 4 options for my patterns. The first one is going to be 1 for A. I'm going to do this one in full, plus the term number minus 1 times by the common difference. And you can see that that's going to give you 4t minus 3. In my second pattern, I'm going to get 4t minus 2, and then 4t minus 1, and lastly 4t. The biggest clue for me is going to be looking at this fourth option, because every time I have a term that is divisible by 4, I'm going to get that the derivative is sine x. And then working from that, I can either work forwards or backwards. So for an example, what would be the 101st derivative? Well, the 100th derivative is divisible by 4, because 100 is divisible by 4. So the 101st derivative must be going back to the beginning, and the 101st derivative would have been cos x.